Good afternoon to everyone. Am I audible to all of you?
Sir, yes, sir, you are audible.
There is some network issue in my home actually, so that's why it's creating a little bit in this session. But nevertheless, so good afternoon to all of you. First of all, I would like to express publicly my gratitude towards Professor S.N. Deepa for accepting the invitation in such a short period of time. Professor S.N. Deepa completed her BTech, MTech, and PhD from PSG Tech, Coimbatore. Professor Deepa has been serving in the post of Associate Professor at NIT Arunachal Pradesh. She has published many books in different in hop computing topics. So now, a very good afternoon to all. So, ladies and gentlemen, please welcome Professor from NIT Arunachal Pradesh. Over to you, madam.
Yeah, thank you, Professor Shantanu. So, good afternoon, my dear participants. So, on this occasion of, I think today is the last day of the session, and I think you're all been for the past, after we had the inaugural session on 5th, I think continuously for the past few days, you're being taught and your knowledge has been enriched with electric vehicles. So, nice to know. So at the session, so the session topic which I've chosen is, I'll share my screen. One second, it is getting connected. I'll share the screen. Yes, you're able to visualize the slide? Yes?
The slide
Your
is not
slide
visible.
is not visible?
Okay,
Yes,
okay,
ma'am, we
okay.
can see now.
Now it is visible?
Yes, ma'am.
Yes, madam.
Ma'am,
Yes,
it is
madam.
visible, ma'am. It is visible.
Visible, madam.
It is visible. Yeah. So, very good afternoon again, my dear participants. So, the topic of this lecture would be artificial intelligence and machine learning in electric vehicles. As of the sessions which we had today till now, yes, you might have known what are the prime important prime important components of electric vehicles. So you might have come across batteries. Okay, so batteries which are so three parts. So apart from all the seats, your accelerators, all those stuff, and the outer body, etc. So the three important components which you would have known for all these 5 days pertaining to the development or the technology of electric vehicles would be first. The prime factor would be batteries. Yes, so the batteries you might have come across all lithium ion batteries and so on, and so many talks would have been delivered related to batteries. And the second one would be motors. Okay, so the motors play a prime role, and so about all the motors also the sessions would have been there. And the third one is converters. Okay, so technically pertaining to electrical engineering part of electric vehicles, so batteries, motors, and converters. Okay, so the converters. So then all the allied components would have been assembled and the operational of electric vehicles would have been done. So basically, if you see electric vehicles, there are so this clause would have been already discussed. So, but in order to the need of why we go for artificial intelligence and machine learning in electric vehicles. So I have to tell about these in-campus vehicles and off-campus on-road vehicles. See, in-campus vehicles, so electric vehicles within the campus. See, for example, we have our own campuses. Okay, so our NIT or whatever it is. So from one place, for example, from the gate we have to go to the department to a long way. Okay, so we might have seen in several temples, in railway stations. So a vehicle. So for example, in campus, so there are sectors which use in-campus vehicles and off-campus. So the off-campus will be on-road vehicles, cars, electric cars, and which is used for several mobilities. Okay, so if you see mobility not only for passenger electric vehicles, so for goods, utility vehicles, so utility electric vehicles for carrying goods, etc. on roads. Okay, so if you see in south, for example, so not in India because I'm not seen either in Delhi or Mumbai. So for example, if you see in a few places, so we can see all these on-road vehicles in a very small sector, and it is growing as day by day. And if you see, we all know Tesla is number one in electric vehicles. So if you see in India, Tata, as I said in my inaugural speech, so they're using the Zebron technology and trying to provide solutions. Okay, so they want it to be so the charging of the batteries, the lifetime of the batteries, the power of the batteries, its withstanding capacity. All the metrics has to be studied because it is going to be a complete replacement of the fuel division. So if you see Mahindra's going, if you see all foreign Koreans, Japanese, all these German based cars like Volkswagen, so everyone are into development of electric vehicles and they are focusing. So because it makes the air clean, so pollution will be avoided, and so on it goes on. And so as this session is more focused on autonomous vehicles, yes, so electric vehicles will be in-campus vehicles, off-campus vehicles, all there are some, you Google it, you get n number of pictures of electric cars, and if you see videos, no, you can see the entire manufacturing. So I was about to, for this session, I was trying to prepare. I see so many videos. So how they are manufacturing electric vehicles, how the food is done, how the tire and how the motor is being placed, and how they are identifying the batteries for utility, how they are going to identify the batteries for movement for 2 passengers or 4 passengers. If it is going to be a long, for example, if you see in few institutions I visited, so I visited VIT Vellore. If you see, when I was staying in there, I've seen all these electric vehicles in order to transport food from one hostel block to the other hostel block. So if you see, so I was asking the one who was coordinating the organizer, so what is this, how, why it has to go. So I went and saw that vehicle. Actually it is not small. So electric vehicles, if you see in this pic, if you see like 2 seaters, 4 seaters, not like that. So there are a big for utility movement. So within hostels, several institutions are using for transporting food from one. For example, they prepare it in boys hostel, they want to bring it to girls hostel. They from canteen, it has to be given to the department blocks, etc. So electric vehicles are being widely used. So now what is this? Why my talk is more on autonomous electric vehicles? Okay, autonomous EVs. See, so electric vehicles. So even though, so what to tell? So if why they're going for autonomous vehicles? So in certain instance, always the driver, because our work time is different. Our work time is different, right? So for example, in many countries, even if you take in Bangalore or in prime like Delhi, all our shift timings, all software companies or hardware companies, their timings differs. So they want, so we want a vehicle, so we can't always make the driver wait for a long hours, last hours. So hence is the growth of autonomous electric vehicles, and Tesla is giving more importance, Tesla and Volkswagen, and just now Ford has entered into autonomous electric vehicles. So without driver, okay, it is fully automated. It is fully automated. So how do they automate? How do they automate? So an electric vehicle, the fundamental components of the batteries, the converters, the motors, all the upper part of the body, how the body is being built, the frameworks, everything is going to be the same. But now, what is the technology? What is the technology in order to develop autonomous vehicles, and not only for public or our use, defense? Okay, so defense plays a major role. And if you see in defense, for example, in certain places, the defense persons, the military persons, does not require, they want only the system, like how drones on the sky, drones, how is the development of drones on the sky, what happens on road, an autonomous electric vehicle is necessary, so that it will be fully sensor controlled, it will be fully automated, so it can track, or it can carry military components or military weapons to the required places. So it is not only for the public aspect, it is more for defense aspects also, and automated, so with no drivers, with no one to operate on it, is being required. So all the autonomous electric vehicles, so if you see all these autonomous electric vehicles, it will be operating on all these fundamental concepts. So we know AI, robotics, expert system modeling, computing algorithms, and if you see machine learning models, computational intelligence, data science, data analytics, everything is growing. Like if you see all branches, if you see now, it has come like computer science and artificial intelligence, or artificial intelligence and data science. So it is growing. So hence, in autonomous electric vehicle sector also, so the concept of self-driven, the electric vehicle, it has to be self-driven, it has to be self-driven, it has to be automated. So you have to program it suitably, and at some place, so you will be given a program to make it control from any other place. Okay, see, for example, so this is, so if you see in this, so as and when it will be waiting, and it will have a sensor. If you see, this person is waiting here, see this screen, so where the person is waiting here, so what happens here, as and when the sensor is being detected, like how we enter a place, if there is a door, so it gets opened, right? So in a similar way, so what happens here, so this is one of the vehicles. So when I was going through the notes of Tesla, what they have given is, it is sensors. So if it recognizes within this distance, okay, so for example, this is distance is, for example, 25 meters. Okay, so they'll give a range. So between 25 meters to 100 meters, if it has been given, so what happens? It will automatically open the door. It will automatically open the door, and he can go and enter it. Okay, so it is automatic sensor. So what happens? So it senses. So the sensors at whatever location it is being placed, so that will sense, and so that he can enter into it. So what happens here? So here, what if? So sensor, just any type of sensor. For example, there are so many distance sensors, all those stuff. So if you sense a person within 25 meters or this, then open the door. That would be the control message which is being written. That will be the control message. So automatically, so if you see in this side, so here if you see what happens, if the fuel consumption, so if there is going to be the fuel consumption, so automatically it will be programmed, all if rules. Okay, so why artificial intelligence? So robots, this can, instead of calling it as autonomous electric vehicles, this can also be called as robocars, this can also be called as robo vehicles. So all if else statements, if it is like this, if the fuel, so if the fuel is getting, the tank is getting empty, so what happens, the signal will be immediately given. So like how in our normal vehicle, so you are able to visualize. Okay, so the petrol is coming, the fuel is coming to E part, right? So you always have like this. So you always have like this. So this is your what to say, this is your F, right? Oh, sorry. So if this is going to be your empty, this is going to be your empty point, and if this is going to be your full point. So what happens automatically it is coming. So as and when it comes to empty, so we are able to recognize. So we are able to recognize that the fuel has got empty and we are going to fill the fuel. Here it will be programming. So automatically, so stations or wherever would be perfectly programmed. So not going more into those programming, okay, because so I just started working with vehicles for I'll show you at the end. So what is the work which I have been carried out with respect to electric vehicles using artificial intelligence and machine learning models. So now why? So the most important thing is why we want to use artificial intelligence, or why you want to use computing algorithms for uh, developing autonomous electric vehicles. Okay, so how is different? So always we will ask why you have done that, what you have done that, how you have done that, and what is the application of that. Okay, so now, so the next part, if you see, so before going into why AI is, why we are bringing AI into this, why we are bringing machine learning into this, so etc. So before going to all these, what is a necessity? Otherwise, can't we do it? So yeah, no, normal electric vehicle is possible. Normal electric vehicle, so with this batteries, motors, and it is possible. So no, I want a vehicle to track without any person. I want it to be autonomous driving. So if you see, I want like this, then no options. You have to go for AI. Then with no options, you have to go for AI. So this AI will be rules, how humans act, how rationally human thinks, how rationally human makes a decision making. That's all is required. That's all. Hence is the growth of artificial intelligence. So the artificial intelligence is not like programming or sitting. No, 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 no. How a human perceives the information, how a human is able to understand the information, extracts the information, and how he is able to make a decision making, how it is going to make a decision making. So those concepts are written in terms of computing algorithms. That's it. Okay, so it is not complex. So everything, so if you say the word artificial intelligence, if you say okay robotics, it is not complex, it is very very simple. It is rules, it is small rules. So based on those rules, the system act. But how many information you are giving to that rules are very very important. How you are writing the rules, you're writing your rules, how you're framing those rules, what, in what way you would think to frame these rules are very very important. So before going into why artificial intelligence, so I have few slides of how the development of autonomous electric vehicles are there. So see, mostly, so I don't know whether you're able to see this. I've taken this from Volkswagen website. Okay, so they are into research of this. So this is from Volkswagen website only. I have taken all these pics. So if you see, they are into development there. How the design technology and how it is being built. With this only they have started. And see, currently autonomous EVs are not used in open public roads, etc. So, but they are expecting, so 2030. So there might be, for example, if kids have to go safely from nearby, for example, within 20 kilometers or within 10 kilometers range, if there is a school. So even the perfect information, if it has come near the door, the information before the gate, for example, before the apartment or wherever you stay on road, so the information would automatically mobile to the parents mobile, and they can drop their kids inside. So and it will be a safe for 10 kids or like that. So it has been planning. So this was one of the prime thing which Tesla has given, the safety, so the measure. So within how many range they can operate these autonomous electric vehicles. So if you see, general electric vehicle is there, basic electric vehicle is there. So you have autonomous vehicles. So and autonomous vehicles. So this is also autonomous vehicles. So mostly it will be used for moving people, and it will be used for moving kids, and so always it will have mobility assets service. So now if you see, now as I was telling you, why they choose, why they choose using artificial intelligence, why AI techniques come into picture. during the development of autonomous vehicles. Okay, so now I want you to interact. Okay, so which is the most complex system in the world? Anyone, you can at least answer in chat box. Which is the most complex system?
Human being.
Human being, perfect. Okay, so the most
Human brain.
complex, yeah, perfect. So the most complex system in the world is humans. So you accept it, right? So the most complex system in the world is, why? Can I ask this question? Humans. Can you tell why?
Because the way it evolves itself, depending on the past experience, and survives all the odds. This is unparalleled. And it
Okay.
has intelligence. It decipher the correct and wrong.
Okay, Dr. Nitin. Yeah, I think so. If you see, humans is more complex systems. See, how many system? What is a system basically? Can you tell why human system or an electric vehicle system, a thermal system, a mechanical system, a management system, for example, an ERP system? Why everything is being called as system? Why system? Respiratory system, nervous system, muscular system, reproductive system, excretory system, cardiovascular system, respiratory system. Why everything is called as system?
Because it accepts an input and processes the input and gives the response as an output.
Okay, so few people are asking some questions in the chat. I will answer all those after the session is over. Okay, so Amit has asked what different challenges autonomous EVs have when compared with UAV. So it is just in the development part. It will be most in the development part. Designing the expert system module is the main challenge. Okay, so expert system module, no, so it should not get struck. So hence at that point, so designing of expert system module will be different. So that is the answer for this question. So all the questions I'll answer after the session is over. Okay, so now if you see system, okay, so why system, as professor said, yes, it is used to do some operations. See, system is arrangement of some components. System is arrangement of components. For example, an electric system, it comprises of a motors, it comprises of some voltmeters, ammeters, etc. It is a system. If you see respiratory system, our respiratory system is built with your esophagus, your lungs, and your respiratory tract, etc. So if you see your excretory system, you are having your urinary path, you have your bladders, you have your anus. So it is comprising of your excretory system. You have your cardiovascular system. You have components. So components. An electric vehicle system, an EV system comprises of batteries, comprises of motors, comprises of what to say, your converters, comprises of tires, comprises of a base and frame, body frame, yes, seaters. So many components build a system. Hence, in this world, everything will be called as a system. Management system, yes. Stock market system, yes. Biological system, yes. Botanical, zoological system, yes. It's so many components comprises physical components or real components. So many components are comprised and a system is formed. How do system operate? How do system operate? Okay, so you have so many so now I think you know what is a system and how do a system operate. So this I'm calling it as a system, right? So how do a system operate? How a human system operates? How a human, yeah, through commands. So it will be basically, so it will input commands, yes. So you can simply call it as, yes, as professor said, it is inputs. So commands are in the form of inputs and you have outputs. So why human system is complex? Because why human system is complex? So unless and otherwise we are controlled, our biological neural system is controlled, and you want to be like this for this seminar program for 1.5 hours. You wish and you decide yes, but what happens at sometimes there is some non-linearity which would have built. Okay, so unknowingly, knowingly or unknowingly, and what we'll do, so we have some deviations. So from what we are really focusing, what we are really concentrating. So even though you want to put your attention for more than 6 hours, it might not be. Sometimes you will go, you will not be in a perfect in that linear mode. So hence, not at only perfectly at 12 o'clock I will be hunger. No, I can't tell. I can't tell. Okay, so I might have my hunger even at 2 o'clock. It is not linear. Okay, it is, if it is going to be linear, for this input only this has to be the output. Only if it is linear, for this input only this has to be the output. So if input is going to be there, if it is going to be there, for this input only this has to be the output. Okay, we can't tell humans so many inputs. So we are all faculty members and even students, all scholars are there in this FDP. So but we can't tell. So in a class there are 60 students, you can't tell, you are giving the same input to each of the student, but the performance of each of the student gets differed. Yes, yes, yes. So everything is not linear. So there is non-linearity. There is non-linearity. Okay, so this non-linearity has to be handled. This non-linearity has to be handled. Hence, because of this non-linearity, human system is called as a complex system. So, okay, so not deviating from our topic. So as I was discussing on why we are using artificial intelligence. Why? So you accept what is a system. So now this system is our electric vehicle system. Okay, so we'll have, since our workshop is on recent trends in electric vehicles, our system here is going to be EV system. So many inputs. So as humans, how many inputs we have? As humans, how many input we'll have? We have only one input. Do we have only one input? Yes or no? Only one input or so many inputs?
The number of inputs, ma'am.
Number of inputs, yes. So we have number of inputs. So there will be number of inputs. So whether how many outputs we'll have? We'll have only one output from our side. As humans,
One
how
output.
Yes, yes, Professor Chandrasekhar sir. So if you see here, number of inputs and number of inputs. So you have multiple inputs. Okay, so in your EV system also, so you will have multiple inputs. Okay, so by means of programming, so via sensors, if they are going to build autonomous EV system, so you will be having number of inputs will be there and its output. So a door is open, it is an output. If a seater is being seated and the distance it has to travel and at what point, so he would have messaged. So from his phone, the information would be given to this autonomous EVs, like so I have to get down after 10 minutes based on the timing. No, mostly it will be based on the kilometer. So at second kilometer, or how it is programmed based on stops or etc. So that I have not gone into the depth of the programming concept. Okay, so it will have several inputs, several outputs. Okay, so as we're all more engineers, right? So we're all engineers. As engineers, what is your duty as engineers? We're all professionals. We are engineers. As engineers, what is your what do you feel is your duty? Yes, dear participants, as engineers, what you are for? Whether you are a design engineer, whether you are a quality engineer, whether you are a program engineer, whether you are in in the development side. So as engineers, what is your key task? Key task as engineers. What have you learned from schooling, right? So we have started our this from schooling, from college, and we have gone research, and all we have gone till our PhDs, and we have gone to postdocs, etc. What have you doing so far? What
Application
have
of technology to develop a product which is
Yes.
basically useful for the consumer.
Consumers, perfect. But all do you accept, for example, we are for problem solving? Do you accept this? Problem solving? Do you accept? So when we have manufactured and we have carried out all, the application has to be used for the end users, consumers, to make the work at ease. Okay, so we'll make up ease. Yes, Dr. M.A. Raja, he is given in the chat box, is to design a system for problem solving. Yes, so our ultimate would be problem solving. So we have started with Ohm's law. Yes, physics. Okay, so not electrical. So we have started our thing with Ohm's law. So V is equal to IR, all your Kirchhoff's current law, your Kirchhoff's voltage law. You have gone with your circuit analysis, all your Thevenin's theorem, maximum power transfer theorem, superposition theorem. Then you have gone with your network analysis and synthesis. Motors on one side, your motors, your AC machines, your DC machines, your transformers, speed control, their OC characteristics, your SC characteristics. So motors on one side, transformers, all-day efficiency. So what is the transformer, coolant, and efficiency of the transformer. And if you see on the other hand, a power system, how generation, your transmission, your utilization, your traction, and your your analysis per unit, why you go for per unit. On one side, your electronics. Okay, so your electronics on one side, electronics, so general electronics, so all your transistors, your UJTs on one side, your power electronics, your solid states on the other side, then your microprocessors on one side. All what you have done in your engineering, you have tried to find solutions to problems using equations. You accept it? You accept it?
Yes, madam.
Or yes, so you accept it. So we have done all problems. So we have started with our third sem, started with circuit analysis. You have built your control systems, your power systems, your microcontroller systems, your embedded system design. Then it is moving to your computational intelligence, your artificial intelligence. So we were focusing, if I know what is the current flowing through the circuit and what is the resistance, then I'll be able to calculate. So you have solved problems. You have solved problems. So now I'm asking very simple question. Okay. So now I'm asking you very simple question. So please, so S plus 1 equal to 0. What is the value of S? S plus 1 is equal to 0. What is the value of S? What's the value of S is equal to -1. Perfect. Why you should think so much? So now I'm asking. So S squared plus 3S plus 2 equal to 0. Can you tell me what is the value of S?
-1, -2.
-1, -2. Perfect. Okay. So -1, -2. So now I'm asking. Okay. So S cube plus 6S squared plus 11S plus 6 equal to 0. Now can you tell what is the value of S? First one is a normal equation. S plus 1, it's a first order equation. It's a linear equation. It's S is equal to -1. S squared plus 3S plus 2 is a quadratic equation. It's a second order equation. So S squared plus 3S plus 2 equal to 0. You were able to answer me. S is equal to -1 and -2. So now I'm asking another question. So I've increased the, it's a cubic polynomial. Okay, it will not be an equation. It's a polynomial equation. So it is S cube plus 6S squared plus 11S plus 6 equal to 0. Now I'm asking you what is the value of S? What's the value of S? Priyadarshini, I think you answered for one. Takes times to solve. It's just a third degree. It's Professor Raja has said it takes times to solve. No. Why? So it is a cubic polynomial. So we have so many tools. We have been into calculations. We have been taught. But for cubic polynomial, so if you see for this, -1, -2, -3 is the answer. Okay, so S cube plus 6 square plus 11S plus 6. Now I am again increasing the complexity of the equation, say S power 4, etc., S power 5, etc. Okay, etc., S power 20, S power 100, it goes on. About from cubic polynomial, it goes to S power 100 and etc., it goes on. So can we solve? Can we solve? Why you have been taught engineering, you have been taught mathematics. So is it possible to solve? It is possible to solve, but takes time to solve, as it is said. Okay, so now why we are not able to solve this? Why and how to solve this? See, you were able to find the solution. Okay, see now why artificial intelligence? why people speak on artificial intelligence, why expert system design has come, why robotics are based on artificial intelligence. See, always the problem is not going to be simpler. The problem is going to be simpler means s plus 1 is equal to 0. The problem is simple. S squared plus 3s plus 2. Again, the problem is simple. You know, minus b plus or minus root of b squared minus 4ac by 2a. Okay, so you take the coefficients, you substitute in it and you evolve. Next, if you see s cube plus 6s squared plus 11s plus 6 is a cubic polynomial. So you will put minus 1 plus 1 minus 2 plus 2 and you will try to solve the problems. After then, if you're not able to, then you reduce it to a quadratic. Then what happens as problem complexity goes on increasing, you can't use minus b plus or minus root of b squared minus 4ac by 2a. So minus b plus or minus root of b squared minus 4ac by 2a, it is for a quadratic equation. It is so simple. It is so simple. It is so simple and it is being applied only when it is second degree. Okay, when it is second degree. But all real-time problems, my dear participants, all real-time problems will not be simple. Okay, so always we are to handle complex data. We are to handle complex problems. So electric vehicles, autonomous electric vehicles will not have only one input or one output. It will have multiple inputs, hundreds of inputs, thousands of inputs, and you will have several outputs. As humans being a complex system, our ultimate is our sixth sense and how we make decisions at the right situation. We have so many inputs. Your food is an input, your water is an input, these are for driving your energy level and maintaining your energy level. But your knowledge inputs, you receive your knowledge inputs from your parents, from your siblings, from your from books, from gurus. Okay, so from from your friends, you will have knowledge inputs, all from your medias, your onlines, etc. So many resources are there. So you have knowledge inputs. What is your output? What is your output basically? Your output basically will be the decision making and how you evolve based on a situation, how you react and how you evolve towards the solution is based on all these inputs. Okay, your performance, not only performance, your performance, it does not mean you achieve 100%. No, you're completely performance. No, not decision making at right situation, making a right decision making is what over all the experiences what you have gathered over the years, you put it and you solve. So hence, if you see in this case, so for simple you have solution. When it is complex, you can't need. So this I will put it in a different way. See now, why suddenly you came across integration and differentiation? Algebraic equations I was showing, s cube, etc. These are going to be polynomials. Why suddenly after 10th standard you were being known of what to say, differentiation and integration? You studied, right, everyone? we have come across. Yes or no?
Yes, ma'am.
Yes. Why differentiation and why integration?
Since the complexity will be introduced more and more to us, so we need to get solution. For that, we are trained towards that one.
Trying towards that one. Yes, Professor Chandrasekhar. So that is one of the answer. See, now I'm asking you in another simple. See, for example, a curve. Okay, so we were in our kindergarten. Okay, so your LKG, your fifth standard, your 10th or 12th, you will have put 12th, your UG, your PG, your PhD, etc. So based on time, so you might have started in 1970s, for example, here 1975, for example, around 2000, no, so it will be like for example UG, if it is going to be 1970, so you'll be completing your UG in 1990s and around 2000, so etc. It goes on. So time scale, your performance scale, so LKG, your knowledge level, your 5th standard, your knowledge level, your 12th standard, your UG, your PG, your PhD, and etc. So what is this curve? What is this curve? This curve is increasing, right? You accept it is increasing. You accept, anyone? It's increasing, right? Participants, anyone can answer. Yes, ma'am. Yes, Neela is saying yes, ma'am. So see here, so everything varies with respect to time. Okay, so as time changes, so what is happening based on time, it is changing. So hence your differentiation integration, if you see, why you suddenly always your equations, you're studying polynomials and algebraic equations, so suddenly they brought dx by dt. Suddenly they brought dx by dt or integral dt, for example, because time. So any system in the world. So whether before, so when was electric vehicles started? Okay, so if you see 1900s itself, it has started, but full phase. So in this current generation only more on electric vehicles. So everything is varying with respect to time. So when you want to model a system, when I want to model an expert system, I should model it based on time. Since time is very, very important, since time is everything is varying with respect to time. So I want to design an autonomous EV system so that it operates within a specific span of time. Okay, so hence what happened earlier, conventionally, so before your artificial intelligence or expert systems were there, conventionally what was there, because if you don't know what was earlier, you can't go into the future. You should always know what was previous, then only you can go for future. So hence what happens, so you had your integrations and differentiations, and engineering mathematics, you have studied all those differentiation and integration. And how have you solved these equations? Can you tell how have you solved these equations? For example, differential equations, you would have heard of continuous systems and discrete systems. Yes, so your continuous systems will be like this, and your digital always will react for the unit step. So it will be the digital system. Okay, so for example, continuous system only you will be using differential equations, and for this type, your digital, you will be using difference equations. I think you would have known. Okay, how to find solutions for all this? Okay, so how to find engineering fully? We have studied only differential equations and difference equation. You accept it? Before artificial intelligence modeling, we have studied only solving differential equations. So whether it is power electronic side, whether it is power system side, whether it is control system side, you had all different, whether it is signals and transforms. Okay, so signals and systems. Okay, discrete, digital signal processing, whatever it is, all those, whatever we have studied, we have used only differential equations and difference equations. Do you accept it?
Yes, ma'am. Yes, ma'am.
Yes, we accept. And how do you solve those differential equations? For example, d squared x by dt squared plus 5 dx by dt plus 6x equal to 0. How do you solve it? Take Laplace transform on both sides. Yes or no?
Yes, ma'am.
Yes.
Yes. So Laplace transform. So still now, before the evolution or before we are applying artificial intelligence, how we are trying to find solutions to problems is your transforms. If it is going to be a continuous systems, if always with respect to time, you write it using differential equations, you are going to write it using differential equations continuously with respect to time, t, 2t, 3t, etc. On the other hand, when it is going to be discrete for sampled instance of time, the output is there only at sampled instance of time t, which follows a Shannon's sampling theorem, 2t, 3t, 5t, 7t. It goes on like this, my dear participants. So what happens if it is continuous, if it is going to use this, your Russian mathematician, his work are immense. We are fine, not 1% itself, we can't go near Laplace. We can't go near Laplace. Okay, so how Laplace transforms is being applied? Yes, if you see in several, if you see, for example, conventionally Professor Selva Ganeshan is there in Indian Institute of Space Science and Technology, IIST. IIST Thiruvananthapuram. Okay, so in Department of Avionics department. Okay, so if you see, still he always works with differential equation solving, even for adaptive control, even for applications, even to NASA. Okay, so let artificial intelligence on one side. This is your hard computing. So anything you write it by means of differential equation, you use Laplace transform. And if you see anything you write it as a digital, you write it by means of difference equations. You write it by means of difference. How do you solve difference equations? Your Fourier. How the work of Fourier can be forgotten? Fourier transform. Your DCT, discrete cosine transform, discrete Fourier transform, your fast Fourier transform, your Z transform, your Z transform, your wavelet transform, Okay, see here. So if I want to automatically control the electric vehicles, I don't want artificial intelligence. Okay, forget artificial intelligence. Whether it is possible to control, yes. How to program it? Use all these transforms, conventional methods, traditional techniques. So before soft computing, before machine learning, all are same. Artificial intelligence, expert system, data handling or data science. I'll come to the data because your EVs require more data input. If you want to develop an autonomous electric vehicle, you want to develop an autonomous, even for reverse, etc. You want to develop an autonomous electric vehicle, you should focus on data science. You should, because how many data you're giving, based on the higher volume of data you give, the accuracy would be higher. So hence, if you see in this case, so as and when, so transforms are being used. Now, when your transform fails, when you go for artificial intelligence, now that is the question. So far, for past 15 minutes, I was telling about your conventional, your cubic polynomial equations, you are unable to solve after third degree. If it is s power 4, s power 100, s power 1000, you are not able to solve. And differential equations also, you use Laplace transforms and Fourier transforms. I am telling at one point, you can't apply Laplace transform and Fourier transform. So if I am unable to apply Laplace transform, if I am unable to apply conventional techniques, these are called as conventional techniques. So you might have come across several research papers on EVs. They would have tell conventional techniques were employed. Okay, so when conventional techniques are employed, then you cannot. So when conventional techniques fail, see, very, very important. So what to say? We are all traveled in flight. Yes, flight. Can you tell how many parameters are there? When you want, I want to land the flight. The aircraft is landing. How many parameters will be there? When an aircraft is landing, for example, how many parameters will be there? Can you tell some parameters? Wind velocity, upward velocity, downward velocity, fuel, white petrol level, how many kilograms of passengers inside, what is the latitude, longitude, altitude, at this point, what is the humidity, what is the moisture, etc. How many parameters will be there? How many parameters will be there, my dear participants? How many parameters will be there? How many parameters will be there?
Maybe hundreds, madam.
Hundreds and thousands. Yes, hundreds and thousands of parameters will be there. So many, as Anu says, so many parameters. Okay, so see, so many parameters are there. So when so many parameters are there, how will I write a differential equation, or how will I write a difference equation? When so many parameters are there, I can apply my conventional techniques. I can apply my conventional techniques like Fourier transform or wavelet transform or Z transform only if I have a difference equation or only if I have a differential equation. If I don't have a differential equation, how do I frame a differential equation? The relation between inputs and outputs. So I told you in the initial startup, you have your system, you have your EVS. Okay, so you have your electric vehicle system, you have your input. So for example, it is considered only 5 inputs simply. Okay, so you have some 5 inputs are there. Okay, so 5 inputs are there. So for example, it stops at one point, pickups, etc. So you have a output also, for example, 10 outputs you have, for example. Okay, so fuel, etc., etc. What is the load, etc. So for example, you have 10 outputs, for example. So many inputs, so many outputs. See, what is the differential equation? I have a differential equation. So d squared I is the current, d squared I by dt square plus 5 I of t, I is the current plus 7 is equal to your voltage, 12 V of t. Okay, I have this differential equation. How do I write this equation? How do you get this equation? Mathematical modeling you would have done. So you would have done a mathematical modeling of a DC motor, mathematical modeling of a servo motor, mathematical modeling of a stepper motor, mathematical modeling of a thermal system, mathematical modeling of an actuator. Okay, so we have done mathematical modeling. So you have inputs. How do I derive a mathematical model? Okay, I have so many inputs: flux, speed, torque, voltage, current, etc. Okay, so how flux influences on the speed of the motor. So I derive N is equal to EB by 5. Okay, so back EMF divided by 5, for example. So this is a small equation. How do I get the speed equation? Speed is the output N. Okay, so for example, N, so speed. So, okay, so it is dependent on, for example, simply I'm telling. Okay, so for example, so the input is EB and phi are the input. So based on that, I evaluate this. So how do I get this equation? This equation is called as a mathematical model. Okay, this is my output. This is my output. These both are going to be the inputs. These both are going to be the inputs. The relation between input and output is called as mathematical model. Okay, that mathematical model can be a normal equation, can be a differential equation, can be a difference equation. Right? You accept it. Now my question is, I asked you for an aircraft, how many parameters we have? How many parameters we have? Thousands and thousands of parameters. Can we write a mathematical model for that? Can we write a mathematical model for that? Can we write a differential equation for that? Can we write a difference equation for that? No. It is not possible. It is not possible to write a mathematical model. If I don't write a mathematical model, if I don't write, why I'm writing differential equation based on time? Everything in the world is changing with respect to time. When our institute was started, we would have had only 60 students. Okay, not 60 students. For example, 60 in a batch, we are starting 4 courses. Okay, like BTech EE, BTech Mechanical, BTech Civil Engineering, 4 courses or 5 courses. So 5 into 60, so we'll have 300 students. Second year, 600. New branch we are starting, 600 students. The data is increasing as time increases. So for the first batch, students ask for a transcript. He wants to go to US or London or Australia for going his study. So we have to retrieve the data. So data, that is what data is increasing. So as you want to build an electric vehicle, it has to travel long distance. It should have more battery power. If it is going for defense or military applications, there might not be fuel. Okay, so when it is going inside, there might not be fuel. So it should have a tank which is designed for sufficient fuel and for operating it. If it has a fuel, so automatically it should energize itself, the batteries, so by means of solar or something. So on the top of the electric vehicle, we can have solar panels present, and from that solar, it shall supply power to the batteries. So what happens as time goes on, the data gets increased. So as more number of inputs and more number of outputs are there, it is very difficult to write a mathematical model. So what is a mathematical model? So in several research papers, whether it is a Science Direct paper or an ASME paper, IEEE papers, so you see everyone will tell mathematical model. So why mathematical model? No? Relation between input and output. Just because why you need relation between input and output? Everyone, humans is most complex, and all humans wants to be efficient. Okay, so efficiency. So how do you define efficiency? How do you define efficiency? Output by input. Okay, so you're known, right? So output. So the relation between this input and output is a mathematical model. Based on this input and output, you derive a parameter called as efficient. Our output divided by what inputs we have received will define our efficiency. Okay, so we'll define our efficiency. So what happens? So when several inputs, several outputs are there, I cannot frame a mathematical model. I cannot use any of my computational techniques. Then what technique shall I use? Go for artificial intelligence techniques. Okay, so why? So many PhD defense thesis I have attended, why was exams being expert? So everyone has used so many computational intelligence. They would have used they've used several artificial intelligence techniques, but there will be of no clarity on why. So whether for this electric vehicle problem, yes, so whether intelligent system is required, whether an autonomous system is required, yes, because it has to travel, so we can't have drivers waiting from night 10 o'clock. So there will be people, but at certain time period we might not get some people. So if it is if it is by itself, if it is artificial intelligence, it will be convenient. So you can go, so it will automatically open the door, gets closed. So the program will be tuned. You give a message, it automatically drops at your location. Then based on the program, it will automatically go to the respective starting point. So where it has to finally reach. So hence what happens? That is the applicability of artificial intelligence. So artificial intelligence, why it has been applicable? Because I have so many inputs. I have so many outputs. Using a transforms, normal, you can use a microcontroller chip, you can embed the program, you can write the coding either in C, fundamental. Then you can use any of the software, WinSys or Win51, whatever software. So currently it has gone more than PIC, it has gone. So you can automatically ARM controllers. Okay, so you can automatically download from there chip as exe files into the chip, and you can place the chip, and for the chip you can give interfacings, and you can do it. Okay, you can do it. That's very simple. That is conventional control. But when it is going for artificial intelligence, okay, so I don't need mathematical model. When I don't have a mathematical model, when I don't have a differential equation, difference equation, I don't have any equation, I don't have so in your engineering curriculum till now, we have solved problems in all our examinations. We have solved problems using formulae. What is that formulas? What is that formulas we have used so far? The relation between inputs and outputs. Okay, so the formula is in the form of relation between inputs and outputs, and we have found solution for that, and we have found solution for that. So hence only I have inputs, I have complete knowledge of inputs, I have complete knowledge of outputs. I don't know the relation between inputs. So for example, there is a flight crash. Okay, you consider there is a flight crash. Always we'll see somewhere it is flying over Indonesia or Philippines or any other part of the world. If it is gone, a flight gets crashed, they'll still we have seen in our newspapers. Okay, now they are searching for black box. Now they are searching for black box, like that they'll be telling. So what is that black box? What does that black box basically consist of? So the black box will always have the information of the altitude, longitude, the point at which it is fed. So you can't tell just because the level of the petrol is leaked, the flight got crashed. You can't tell because the moisture in the air was this much grams instead of milligrams, it was more than 100 grams, hence the flight collapsed. You can't tell. You can't tell. Only one parameter influenced for the flight crash, because hundreds of parameters are there. Hundreds of parameters are there. So in your real time, your electric vehicles or whatever design of many utility vehicles, etc. So what happens? There will be n number of datas will be there. So everything has to be suitably controlled. So hence, instead of using all these transforms, so for building autonomous electric vehicles, they have gone for artificial intelligence. Artificial intelligence, there are several clauses. See, neural networks is one clause, fuzzy is one clause, expert systems is in one clause, and evolutionary strategies are another clause. Okay, so but if you see related to electric vehicles, if you see in related to electric vehicles, artificial intelligence mostly focuses on expert systems. Mostly focuses on expert systems via rules. Okay, so via rules. So how they have fusioned, to form rules to design the software module or to design the program module of EVs. If you see, so before going into that, how do you form rules? So now I'm asking you a question. The outside temperature is 21 degrees Celsius. The atmospheric humidity in the air is 0.5 milligram. The humidity in the air is 0.5 milligram and the moisture content in the air is 0.2 milligrams. Now I'm asking you whether rain will come or not. I have given you accurate values. See, my dear participants, I've given you accurate values. So temperature, your temperature is 90 degrees Celsius, 90 degrees Celsius. Your humidity in the air is 2 milligram. The wind pressure or your wind moisture in the air, for example, it is 0.1 gram. Now I'm asking you, I've given accurate inputs. I have given you accurate inputs. Input is not always you will tell, right? As engineers, we tell, accurate input is given, I'll give you accurate output. Now I'm given you accurate input. Now I'm asking you what is the whether rain will come or not. So please answer. Please answer. Temperature is 19 degree. Humidity is 2 milligram. Moisture content in the air is 0.1 grams. I'm asking you whether rain will come or not. Yes or no? Yes or no? Anyone? Yes or no?
Yes, ma'am.
Yes. How are you, Sri Lakshmi, to tell yes? So you're telling rain will come. So now I am asking you, if it is 25 degree and 1 milligram and moisture content is 100 milligrams. Now I'm asking you whether rain will come or not. See, even though input is accurate, we can't tell whether rain will come or not. See, but now, yes, as Raja says, may or may not be. See, now what I'm telling you is, now if you see clouds, you see black clouds, you feel smell of the sand, you feel the wind, you feel the lightning. Now what you will say?
Likelihood can.
What, Professor Nitin?
We can also likelihood can tell. You can't tell exactly. We can say
No.
likelihood of it, yes or no. We cannot say exactly whether yes or no.
Yes or no, but you feel the clouds. You can see so many black clouds. As
We
human,
cannot. Still cannot say.
we cannot say. Okay. See, yeah, we cannot say, but I'm telling, rather than this data, for example, 19 degrees or 2 milligrams or 0.1 grams, etc., moisture. So rather than this, if, for example, you feel some smell of the sand, so rather than knowing this accurate, you can put your human decision making. So if yes, if there is clouds, so there might not rain, but the possibility is high. Rather than your temperature is this and this, we can't predict. Our human brain cannot tell for this values whether we'll get it or not. We can't predict. But if this condition is there, if there is smell of the sand plus there is what to say, your smell of the sand or your trees like that. There is possibility because you make a decision. Now another one simple example. Okay, so rather than this, another simple example. See, for example, if A is of this height. Okay, so for example, 167 centimeters, and his weight is, for example, 55 kg. Okay, I'm asking you to visualize the person A. Another person, okay, so he is going to be of 140 centimeter and of 32 kg. Okay, so another, for example, a person C, okay, so for example, 175 centimeter with 100 kg. Whether we can exactly, okay, so see my dear participants, so person A is like this, person B is like this, and person C is like this. Whether exactly you can visualize how the person will be, whether exactly we can predict, how A will be with 167 centimeters and 55 kilograms.
No.
No, yes, we can't predict. Now I'm telling you. So take any of your friend. Let your friend be Ram. Ram is your friend. So another friend is telling, hey, this friend, no, one of my friend looks like Ram. Looks like Ram. Now can you visualize? Have any one of your friend. Okay, instead of telling this much centimeter and this much height and this much kilogram, if someone is telling you, if he is like Ram, okay, that person will look similar to that of Ram. Now can you visualize or not?
Yes.
Yes, that is human rule base. That is human rule base. See, even accurate values are there. 167, even they will give body mass index. Okay, so 16.2 BMI, body mass index. We can't visualize. If you're going to see a bride or a bridegroom, okay, they are telling the bride is 130 centimeters, the bride is 60 kilograms, the bride's body mass index is 12.6. That is the girl or that is the groom, whether it is bridegroom or bride. Now you marry. Will you accept or not? Inputs are accurate. Accept or not? Yes, come on. We can't. Yes or no? Anyone? If data is accurate, even though data is accurate, can you visualize?
No.
No. That is what. See, no. On the other hand, see how human perceive, how human think, how human makes a human rule base. So if the girl is like yes, what to say, some is some name. Okay, so if the girl is like Sita or the girl is like Kavita, etc. So whatever it is. So now what happens then? They are able to. She looks like her. She will be looking like her, etc. If they say you are able to visualize. So if statements, if. So I want you to bring this. So this if statement are the most important rules when they are using sensors with electric vehicles. So if statements, if for example, if A is like Ram, okay, then B is also like Ram. So many, how much ever you can form the rule base, then output. Okay, so the output is also or else no, like that. So this is expert system modeling. In case of this all, whenever they use sensors, so if you see a person at this distance, 25 centimeters, if then statements, all if then statements. So your AI mostly if it is going to be computing algorithms, it is going to be different. If it is going to be computing algorithms, so then there will be procedures. Each time the computing algorithms learning factor might be updated. But when in case of I'm designing an autonomous electrical vehicle for a short distance, when it is going to be a short distance, then I can go for rules, then I can go for expert system rules, and this expert system rules are primary for autonomous vehicles. So here, so this slide, if you see, why and what do we compute? Okay, so why? So in the EVs, it's one of the real world problems. So it's a real world problem. So I have mathematical model, then go for all techniques, then go for all your conventional techniques if you have a model. Okay, so or you go for problem solving. So solving can either be using mathematical model or without using mathematical model. Find a solution. Solution also you can evolve a mathematical model. If you don't evolve a mathematical model, then you go for AI, then you go for AI methods. So our experience, so how if a student is good, okay, in his you can try for this company, or we can recommend for this placement, etc. So if you don't meet this academic record, then we can train the student. If so many ifs, okay, so not ifs and buts, so many ifs are there. So based on those ifs only, rules are framed. The ultimate of artificial intelligence and autonomous electric vehicles, so whatever material which I've studied and I analyzed, was moreover operating on rules, expert system, rule defining. But how do you define the rules is very, very important. That is by experience. Okay, like how you are able. So we are not able when we are 17, 18. Okay, so 20s we can't judge a people. So when we are in 30s, okay, to some extent you are able to judge people. 40s, okay, again still long way to go. When you are 60s and 70s, we become more silent. You see many people 16s and 17s. So if you see more silent, they out of experience they become silent. Out of experience, so we have studied everything. So there is a saturation point. So silence will be one of the. So how do you frame the rules? How do you frame the rules? When initially when you start for designing an EV with rules like for autonomous artificial intelligence based model, it will not be perfect. So you have to go for testing, you have to evolve so many rules, and framing of rules will be based on experience. But if you have inbuilt, so many teams will be there. For battery you form rules, for motor control you form the expert system design, for converters you form the expert system, for consumption, so how the battery charging and discharging operation, if I want the always the charging to be like this, then you go for designing an expert system design. So it goes on like that. So that is the need. And why, if it is conventional control, a normal EV, no problem, you can go for chip based design. You can have all your simple boards, and you can have your control mechanisms. So but when autonomous, for military, if they are going to design an electric vehicles, it will be automated. So when automation comes into picture, normally artificial intelligence. So artificial intelligence for this purpose, okay, for this purpose of EV will be based on expert rule base. So how do you form the rules? By experience. When you initially start up, you can design. So as a startup project, or you can apply for project in EVs, for automated EVs. So generally we'll get it sanctioned, because automated in defense side, if DRDO, if you see, or there are into requirement of all these automated EVs basically. So hence, so you have to track it, you have to design it, you have to make it run to a particular distance with simple rules. So how sensors, at least 2 sensors, instead of using immediately starting with 100 sensors, you start with like 10 sensors and 20 sensors, and based on the sensor, the tracking can be done, and it can be proceeded, So I think it's already. So what piece of work we are doing? Okay, so we are carrying out. So we started with this work. So we started for using neural network here, because I have not touched in this session. We have not spoken about neural networks, etc. Because only I've spoken on framing expert rules. Okay, so when accurate values, even though accurate values, for example, height is known, the perfect weight is known, we were unable to design, we are unable to judge the how the person will look like. But we are able to, if you are comparing it with this using human decision making, then we are able to make a solution. That is expert rule based. That is expert rule based. So based on the experience, you form it, and then it will be. So there are people. So if you see CDAC, okay, CDAC Thiruvananthapuram, you go and see the electric vehicle division. So n number of people are there. So working in power electronics, working in motor side, working in battery side, working in automation side, working in artificial intelligence side, etc. If you see, CDAC is more focusing on electric vehicles. Okay, so Center for Advanced Computing. Okay, so if you see CDAC, that too more on Thiruvananthapuram division. More people, you can go to the website and see. You can find nearly how many scientists? So around 30 scientists. Okay, so 30 scientists are working with EVs at CDAC Thiruvananthapuram Center. So their special attention is given for AI division. Okay, so special attention for this division. So if you see a small piece of work, okay, so if you see, I think you're able to see this block diagram. So this is one of the work is I've started. It is going still. The output does not thing. So if you see here, so this is vehicle velocity. Okay, so the vehicle speed. Okay, basically what is velocity is its speed. So how an input, how a neural network model. So this neural network model today I'm not included in my speech, but even then, so what happens? How you can work? Okay, so the velocity. So for example, if you see the vehicle velocity and acceleration may be given as inputs. Okay, so based on vehicle velocity, based on vehicle acceleration, you can design. So many inputs will be there, the outputs will be there. So here the extension is always a convolutional neural network model. So it is one of a hardware neural network, right? So in neural, always instead of programming, hardware component has come. So in that, one of the best hardware operative neural network models are convolutional net. So the chip will be called as ConvNet. Okay, the chip will be called as ConvNet, and there are so many others called as ResNet. Okay, so ResNet, all these are all convolutional neural network hardware chips. These are all hardware. So ResNet 72, convolutional net 36. So like this, based on their speed, etc. So they have different varieties of this. So what I want to tell here is, so the most, one second. Yes. So the most see here. So fuel consumption. Okay. The fuel consumption. Okay. Destination point. All the range predictions and the category of driving cycle. Okay, so whether it is initially how it started and how it is going to be, how driving, how the variations, the linear variations will be there, etc. So like that, if you see, all these artificial intelligence modules can be used for predicting how long the battery can stay, how much energy it requires for further movement. So whether there is, based on this, how the driving cycle can be controlled. So in an electric vehicle, how a driving cycle can be controlled. So all this can be carried out here. Okay, so I think can be carried out. So if you see currently what currently if you see, the more focus is on sustainable mobility ecosystem. Okay, so if you see electric vehicles will be there, then you go for autonomous electric vehicles. So the information, see for example, based on energy sector, so when it is going to be, it needs, the battery needs the source. Okay, the battery needs the source. So there can be renewable energy grid. Okay, so over it, as I told you, on the top you can have your solar panels, and separately charging stations can be there, and via networks. Okay, via networks, each of them can be connected, and they can go to the battery charging station, and they can get energized, and they can move on. Each time everyone can be communicated with the respective data centers, and the data centers will be the centralized part to control all the vehicles. So it can go like that. So several, if you see, several researches are being going on artificial intelligence based autonomous electric vehicles. So you can focus on those stuff as well. So I think so we have, yeah, under 10 minutes. I think we can answer the queries of the participants. I think I can stop here, because if I start another modules of neural networks, we can't complete it with a stipulated period of time. I think so. This rule base for autonomous vehicle is one of the prime area of research. You can focus on it, and you can design for predicting how long the battery would last, how long it would, how long the charge would go on, etc. You can use neural networks for prediction for those operations. So this is the applicability of artificial intelligence and machine learning for autonomous electric vehicles, and mostly to maintain a sustainable mobility system. Okay, so any queries till what I have handled, my dear participants?
So now, so it was a very nice presentation, madam. Okay, so over to the participants now. If you have any query to madam, you can ask.
Yes, you can ask in your chat box as well, my dear participants. Any queries? No queries. You can give my mail ID, Professor Shantanu.
Yes,
You can
yes,
give my mail ID, so I'd be happy, because see, not able to cover 1.5 hours, that too online. If it is board, no, we can put all equations, everything, and we can deliver to the best possible. Online, really, it's not comfortable, my dear participants. Honestly.
yes, yes,
It
madam.
is board, no, board or whiteboard, no, all everything would be made more clear. But I started my work with electric vehicles for predicting using convolutional neural models. Just now started, not so much.
Madam, everyone is saying, madam, that your session was excellent.
Oh, thank you. It's
I
my
would
privilege.
like to say, I mean, I would like to thank madam. I mean, in spite of such a problems, he has given this session. So means we all are really thankful to madam actually. So
Thank you.
thank you, madam. Thank you for your kind concern.
There is a question, I think someone has
Okay,
asked.
okay, okay, okay.
What are the major challenges in autonomous vehicle? Yes, formulating, designing the entire expert system. Entire, how you frame rules, how you frame rules, how you frame it so that you enable to go it automatically. It has to, it should not have any hindrance. See, for example, earlier when we are taking reverse, when you are taking reverse in your car, there was no camera. There was no camera. Always you go look into the side and you'll be taking a reverse. So once the camera is there, you don't need to see, you're seeing. So, but how much work is being involved in bringing that camera? So that is rule based design. So camera, visualizing, back till then you will be having. So if you see cars, there will be signal which is being given. Okay, so ABCD, if you would have seen the cars with automatic control, you will see ABCD. When it goes to the D level, siren will be high, you can stop, because otherwise you will go and hit some vehicles. So it will be like that. So hence, so the major challenges, if you see in autonomous, designing the rule base. Any effect of Dr. Tripati has asked, any effect on electric vehicle speeds as compared to other vehicles? See, that is what one of the main aim of Tesla is, no compromise on speed. Tesla is designing. So you go to Tesla. I visited just for this workshop and for this FTP. I visited all the websites of all the manufacturers of electric vehicles, and I saw all videos. They don't want to compromise on the speed. So electric vehicles will be in par with other vehicles. That is the total design aspect which automatic electric engineers are looking for, Professor Tripati. Any other queries, my dear participants? Autonomous of EV, is it possible in India? Sure, why not? We are the best. Indians, we are the best. So we can get it. We can do it. It is not, it is there, I think. Tata is developing. And Mahindra is also focusing. And any policy government to plan ensure such system. See, I have not come across any government plans, but we can Google and we can check. Naturally, they will give. So what kind of traffic signal we are forcing to control hybrid traffic? See, traffic signal will be normal. Traffic signal will be normal one. Even hybrid traffic, so that is always enhancing. That's always being enhancing only. Okay.
Yes, ma'am.
Yes. Any other queries? Yes, someone is asking.
Ma'am, still we are all electrical engineers, even though
Yeah.
the electrical engineers do not have an electrical vehicles with them. Is there any reason?
No, we can have one electric vehicle. Why not? That's up to us. We should be first, as electrical engineers, we have to travel in electric vehicles instead of using the fuel cars. Yes. So we have to start. There should not be starting trouble in having an electric vehicle. And it is best. Tata, many vehicles are there. It is really good. My friends have. I don't have one, but my friends have. It's good. In Bangalore, all EV is common.
Hello.
Yes. Yes. Any other queries? Over to Shantanu, sir.
Thank you, madam. Thank you
Thank
for
you.
your such an interesting session. And
Thank you.
in spite of your such a problem, you have attended the session actually. So thank you very much. And I would also like to thank the participants for being present for this session and for their kind patience. Okay, initially. So
Okay.
so
So
that's all.
Once again, I'd like to thank our director, Professor Dr. Pinakeshwar Mahanta sir, the registrar sir, the HOD of the WE department, Dr. Abhik Banerjee sir, the program coordinator of this ATL FDP recent trends in electric vehicles, Dr. Shantanu Chatterjee, and all my fellow colleagues of the WE department and all the participants and all the supporting members for making this workshop FDP more successful, and for all your patience listening. So thank you one and all. Thank you so much.
Thank you, madam.
Thank you.
Ma'am, which battery give you best performance, ma'am? Lithium-ion battery or some other batteries, ma'am?
See, naturally lithium, lithium only, because still works are going on. But versatile, lithium. Lithium ion. If you see Mini, you can Google Mini. I'll put that in chat box. Mini. Mini is best for electric vehicles. They have spread there is a manufacturing plant of electric vehicles. I visited at Hosur near Bangalore, no, in Tamil Nadu. Within Tamil Nadu, there is Hosur. It is there. So Mini. So you can it is a company. So you can check. Mini is using lithium ion. Mini is using lithium ion only. This you can do projects with Mini. You take this name and you can get collaborated even for startups. Okay. So thank you, Shantanu sir. I think we
Thank
can
you.
end the meeting.
Thank you very
So
much.
much. Thank you.
Okay. Okay, madam. Thank you. Okay, so the link for the test actually will be forwarded to you. Actually. Fine. Hmm? Okay. So the link for the test will be forwarded to all the participants sharply by 4 o'clock in the evening. Okay. And it will be consisting of 30 MCQ questions, which you'll have to answer within 30 minutes. Okay. So most probably by 4:30, the questioning sessions will be over. After that, we'll be having our feedback session as well as our means concluding ceremony. Fine. Thank you. I will share the link for the test as soon as possible. Probably within means 5-4 minutes, the link will be shared, and you can start it now also. No problem with that. Okay. So by 4:30, you please complete it, submit the answers, so that uh, I can evaluate. Thank you very much.